Alright, another draftphysics.com, debatephysics.com also. Video presentation, a short video, sort of trying to make it clear that the kinetic energy formula is unviable. So the theory, basically, their kinetic energy theory, it has a stipulation in it about creating momentum when things collide with each other up to a maximum of 2. So if you throw a rubber ball at a brick wall and it bounces back 100%, you can have the expectation that there's twice the momentum in the wall that isn't moving, is kind of the argument. And frankly, it doesn't make much sense. So in a simple Newton's cradle, and I'll show the experiment, where you have a 1 to 3 ratio, they say when this 1 comes in with 100 momentum, I guess I should have made that clear. Ooh, it's missing. Alright, 100. And so it has a mass and velocity, we'll just say it equals 100. They collide. The momentum theory, Newton's theory, or my argument would be, is that if this is a certain amount of energy and it doesn't matter which direction it's going, scale or vector, it's all nonsense. And so 25% goes this way, 75% of the momentum goes that way. And the kinetic energy theory says it's 50 is the reflection, and 150 is going forward. So you've essentially doubled the amount of momentum in a direction. And then when these two objects now come back and hit each other, somehow we're supposed to say that no, we canceled out all that extra kinetic energy that we made. So we made 150 momentums in a direction. It comes back into a Newton's cradle and somehow disappears, and we're back to just 100 again. So somehow the kinetic energy is made, we get extra energy, then the reflection, then the two objects come back together again and the energy disappears, and then it reappears, and then it disappears, and it reappears, and then it disappears. Making little or no sense to me anyway, as a viable theory. So we'll go to the video and you can see for yourself. So the ball is going to come in now to a mass 3 times the size. Now the expectation would be is that there wouldn't be an ability to transfer the energy completely between these objects, but clearly there is if they're both moving. So that's the catch. So in the first impact, both of them will move in their separate directions. Alright, so my argument would be is this one clearly doesn't have 150 momentums, but whatever. And that really what it's done is taken 75% of the energy is now moving the 3 mass, and 25% is what you get as a reflection. So you get a minor amount of energy back in the opposite direction. And because this is gravity, it does look like it goes a little further than 25% in distance, but that's only because the bottom of a circle is flat and the sides are up and down. So the harder bit to move is that this inch is harder to move than this inch, because 1 inch is going up against gravity, the other inch is just going sideways. Anyway, continuing. Now they come back together. So momentum says this one has 75, this one has 25. Their theory says this one has 150 and this one has 50. Alright. And then they collide again, and you get back essentially what you started with. This one stops moving, all the energy goes back into the small object, and it almost goes back to as far as where it started. So clearly it's only 100 momentums that we're getting in isolation. That's all that exists, as the oscillator is showing us here. You're putting 100 into gravity and you're going to get 100 back again. And it just continues with that process, where now you're doing the division, 3/4 one way, 1/4 the other way, and then they'll come back together and do the same thing, and you'll get, whatever, 80% of the energy back, or some percentage. You're losing energy as it goes on, and that's typical, but clearly it doesn't demonstrate this extra energy theory isn't revealed here at all, and it would make no sense to say you have 200 momentums colliding, and yet you only have 100 come out of the collision. So you'd have to explain where the momentum disappeared to, just as you have to explain where the extra kinetic energy came from. Alright, so leave it there. Yeah. Okay, so till the next time, such. It's not a good theory.